In this video, we're going to talk exclusively about chords. And actually, that's a lie. We're not going to talk exclusively about chords, but chords are going to be the main focus of this video. Now, if you watched the previous video, you know that chords were mentioned a little bit, so you should have an idea of what they are. And if you forgot, they're just a segment with their endpoints on the circle. But chords are just so awesome that we needed to make another video about them. So, before we get into chords, we need to know what central angles are. And if you look on the left, you'll see that those angles, AOD or DOB or AOB, are all angles that have their vertex on the center of the circle. So that's the definition of a central angle. An angle that has its vertex on the center of the circle. That's why it's called a central angle, because it has its vertex on the center of the circle. And if you look at the pictures on the right, none of those angles have their vertex on the center of the circle. And there's some, well, before we talk about that, you need to know what an arc is. And an arc is just a piece of the circle. You could think of it as that, a piece of the circle. The technical definition would be 2 points on the circle and a continuous unbroken part of the circle between the 2 points. So if you look over on the left, this AB would be an arc. It's measured in degrees, and you often have to use that the whole circle is 360 degrees to figure out how many degrees an arc is in questions that you'll be doing. The central angle has the same measure as the arc that intercepts it. So what the heck does that mean? Well, I'll draw you a picture. So here's a circle, and I'm going to make a central angle that is 90 degrees. So I'm going to put the center right here. All right. Could have a New York Knicks theme circle, blue and orange. And I'm going to draw a 90-degree angle, just like that. Alright, so I drew this angle so that it was 90 degrees. Now, if you look at this arc that it intercepted, and what that means is the arc that's formed when the central angle crosses the circle. So this arc that I'm drawing in yellow, that would be the arc that's intercepted by the central angle. Well, that arc is also going to be 90 degrees because the central angle always has the same measure of the arc that intercepts it, and vice versa. And it makes a lot of sense because if you look at the yellow part of the circle, that's about 1/4 of the entire circle. And how many degrees is an entire circle? Well, 360. And what's 1/4 of 360? 90 degrees. So if I ever forget whether central angle is the same measure of the arc that intercepts it, or half, or double, I always just think back to this easy example. And I draw an angle that I know is 90 degrees, and I see, alright, what fraction of the circle does that intercept? And since 90 degrees is 1/4 of 360, it makes sense that the central angle is the same measure as the arc that intercepts it. Alright, and just another quick example. If I had this circle over on the upper left-hand corner and drew like a 120-degree angle, now I'm just like eyeballing it, then that would be 1/3 of the circle, because 1/3, this arc would be 120 degrees, 120 over 360 is 1/3 of the circle. Now, that might make a lot of sense, but the reason why I did that is because I want to now compare it to inscribed angles. And if you look on the left and look at angle ABC, that would be an example of an inscribed angle. And inscribed angles are just angles that have its vertex on the circle, so different from a central angle, and also the sides are made up by chords. So if you look at AB and BC, those are both chords. And if we just go back to central angles real quick, though the sides of the central angles are made up by radii. So, and if you look on the right, none of those angles are inscribed because none of those angles have sides made up of chords and also have the vertex on the circle. Now, the main thing you need to know about inscribed angles is that it's half the measure of its corresponding arc. Alright? So, let me show you an example. Let's say we had a circle, and I'm going to draw an arc that's 180 degrees. So think to yourself, right, 180 degrees, so what's that arc going to look like? Well, since we know 180 is half of 360, a 180-degree arc is also a semicircle, and a semicircle is just a technical word for half of a circle. Now, if I inscribed an angle so that it intercepted that arc, it'll look like this. And again, I'm just using freehand right now, but imagine that I used a compass to draw the circle and a ruler to draw that angle. If you look at the angle, it looks about 90 degrees. And I know that the arc that it intercepts is 180 degrees. So, if I'm ever taking a test and it has inscribed angles on it, and I'm not sure, are inscribed angles double the measure of the arc that it intercepts, or is it the same, or is it half? I think back to this example and I say, well, if I inscribe the 90-degree angle in a circle, it's going to cut the circle in half. Alright? So, those are two facts that you need to know going forward, and they're big. Here are a couple other conjectures dealing solely with chords that are really important to know. So, if two chords in a circle are congruent, then their intercepted arcs are congruent. So, how can we use that to help us solve this problem? Well, if you look, it gives us one of the arcs right here is 66 degrees. Boom. And all the other arcs are intercepted by chords that are all congruent. And we know that one of those arcs is being labeled W. So, all of these remaining 1, 2, 3, 4, 5, 6 arcs all have measure W. So if I wanted to figure out what is W, how many degrees is W, then I can use the fact that all of these arcs, all the W's in the 66, have to add up to 360. So let's do that. So I have 1, 2, 3, 4, 5, 6 W's. So 6W plus 66 is going to add up to 360. I'm going to subtract 66 on both sides. So I get 6W equals 294. And then I do 294 divided by 6. And that comes out to 49. So I know that W is 49. So that might help us find Y. Because if I know that this particular arc right here that I just drew in is 49 degrees, then I know that the central angle right here has to be 49 degrees as well, because this central angle is intercepting an arc that's 49 degrees. So I can use what I know about isosceles triangles to help us find Y, because all radiuses in the same circle are equal, because every point on the circle is going to be the same distance from the center of the circle. So I got an isosceles triangle right here, so I also know that this angle right here is Y. So if I wanted to figure out what Y is, I would say, alright, 180 is equal to 2Y plus 49. So if I subtract 49 on both sides, I get 2Y equals 131. And if you divide both sides by 2, that will come out to 65.5. Now, if I wanted to figure out angle X, well, angle X is an inscribed angle, and it intercepts a pretty big arc. So I'm going to really draw angle X is an inscribed angle that intercepts a pretty big arc when I just drew it in blue. Well, if I knew the measure of the arc that it intercepted, then I could say, alright, well then X has to be half that measure. So let me pick a new color so we're not confused. Actually, you know what, I'm going to exit this drawing real quick. And let's just focus on X now. Well, to figure out X, again, this angle intercepts this arc, which is, well, let's figure it out. This is 49 degrees, this arc is 49 degrees, this arc is 49 degrees, this arc is 49 degrees, and this arc is 49 degrees. So it's 1, 2, 3, 4, 5 angles, or arcs, that are 49 degrees. So that's going to be 200 from here to here is 245 degrees. Let me just double check that to make sure I didn't mess up and giving you false information. Alright, I didn't. So X, since it intercepts the green angle X, intercepts that orange angle, that's 245 degrees, x has to be half of that. So 245 divided by 2 comes out to, oh man, sorry, should be able to do this in my head, but I'm doing a lot of things at once. Alright, 122.5 degrees. Boom. So, we just used a lot of things that we just learned to figure out that problem. Alright, let's move on. If two chords in a circle are congruent, then they determine two central angles that are congruent. So it's pretty much like the previous question, or conjecture we just looked at, but now it's talking about central angles. But that should make a lot of sense because we know central angles and the arcs that they intercept are all congruent. So, the perpendicular from the center of a circle to a chord is the bisector of the chord. So, can't open it. That's stupid. Alright, let's just roll with it. So, what that means is that if we have a circle, so I'm going to draw a circle, and I have a chord, looks like that, starting to look like a Ninja Turtles character, and here is the center of the circle. If I draw a line from the center of the circle to the chord so that it's perpendicular to that chord, it's also going to cut the chord in half. Alright? And I'm sorry I couldn't open up this file to show you how it worked, but I'll show you in class. And vice versa, the converse is also true. And that's actually a typo right here. It says this is the inverse of the previous theorem. That's a typo. It should say converse. So that means that the perpendicular bisector of the chord passes through the center of the circle. So now it means if you had a circle and drew a chord, and there's the center, and you drew a line starting at the middle of that chord so that it was perpendicular to the chord, it would have to hit the center of the circle. So, two important facts that you need to know. The chord distance to the center conjecture says that two congruent chords in a circle are equidistant from the center of the circle. So, if I knew that CD and AB were both equal, then I can also conclude that EF and FG were equal because both of those represent distances from the center of the circle to two chords that are congruent. And now I want you to pause the video and just take this quiz real quick. Try to match up in your head all the vocab words on the left to the figures on the right, and then when you want to see the answers, hit pause, or unhit pause, we'll hit play, and you can see what the answers were. Alright, so congruent circles, that would have to be F, because it's two circles with the same radius. And concentric circles would have to be E, because those are two circles with the same center. Radius would have to be C, OE, because that represents the distance from the center of the circle to a point on the circle. A chord would have to be A, DC, because that represents a segment with its endpoints on the circle. A diameter would have to be D, because that represents a chord that goes through the center of the circle, or the biggest chord possible. Tangent would have to be TG, because that is a line that hits the circle at exactly 1 point. Central angle would have to be J, PTR, because that's an angle made up of two sides that are radii and also has its center on the circle. Minor arc, and we'll get more into arcs later, so I don't expect you to know this at this point, but minor arc would have been RQ, and a minor arc, so that's G. A minor arc is just an arc that's less than 180 degrees of the circle. So notice how that's less than half the circle, RQ, so it's a minor arc. Major arc would be something like PQR. It'd be something like I. Because if you go around, and I'll go in green, from P to Q to R, that would be more than half the circle. And then a semicircle would have to be PRQ. So if I do that in yellow, a semicircle is exactly half of a circle. So a semicircle is an arc that's exactly 180 degrees. Alright, I hope this video was helpful, and have a good one.